Okay, welcome back to another video on the Maths channel. It's your teacher, Ms. Lim here, and in this video we're going to be looking at the limiting sum of a geometric series. So, by the end of this lesson, you'll be able to explain the concept of limiting sums and evaluate the limiting sum of a GP. So let's have a look at the first part of this lesson. Consider the series 1 plus half plus 1/4 plus 1/8 plus etc. all the way to half to the power of n. Now, is this series equal to infinity, or does it have a limit? Okay, so normally when we have a look at GPs, let's say we've got 3, 6, 12, 24, 48. We can see here that's got a common ratio of 2. It just keeps doubling, right? And if we were to add all of these together, because we keep adding numbers that are bigger and bigger and bigger, it'll eventually, it's going to add to infinity. However, for this series here, we can see that the common ratio is half. Half divided by 1 is half. 1/4 divided by half is half as well. So we can see here that it's got a common ratio of half. Hence this, the base of half. Now, every geometric series which has the absolute value of the ratio is less than 1 converges to a limit. So what does it mean? It means that it doesn't, when we add them together, it doesn't sum to infinity or negative infinity. It actually approaches an actual number. So here's an example. We've got 1 plus 1/4 plus 1/16 plus 1/64, right? So if we have 1, we add 1/4 of that plus another quarter of this one plus another quarter of this one, etc. We can see that when we add the shaded areas, it's not going to equal to infinity. It's going to approach, it's going to converge to some number. So here's our formula. This is the formula that we looked at from the formula sheet in our last video. The sum of the first n terms is equal to a times 1 minus r to the n over 1 minus r. And we use that when the ratio is less than 1. Okay, so remember here's our formula sheet. We've got two formulas, the green one and the blue one. We use the blue one when the ratio is greater than 1. But we can use the green one when the ratio is less than 1. In this case, here, the ratio is less than 1 because it's, well, in this one here, it's half. In this one here, it's 1/4. Okay, 1/4. Because if I were to split this up, that triangle there is 1/4 of the big one. So because the ratio is less than 1, we can use this formula. But like I said before, in the previous video, it doesn't matter which formula we use. But for the sake of this video, I'm just going to use this one. So what happens when the absolute value of the ratio is less than 1 as n approaches infinity? Well, we're going to look at the formula here. This part of the formula. We know that if the absolute value of the ratio is less than 1, well, that means that the ratio is between minus 1 and 1. Then as n approaches infinity, as n gets really large, r to the n approaches 0, right? So here we've got half to the power of, let's say, 100. Let's see what we get. Half to the power of 100. We get something really small, right? Because it's times 10 to the power negative 31. If we do it to the power of 1000, oh, I guess our calculator can't compute that, but it gives us an answer 0. It's not actually 0, but it's approaching 0. Okay? So what does that mean? Well, in this formula here, we're going to replace r to the n was 0. We've got the first term times 1 minus 0 over 1 minus r. Well, we can simplify that to just a over 1 minus r. And this is the formula that we use for the limiting sum of a GP. So here it is in our formula sheet, right here. Now we only get a limiting sum when the absolute value of the ratio is less than 1, or if the ratio is between -1 and 1. Okay, so sometimes a question might ask you to show that it has a limiting sum. You need to show that the ratio is between -1 and 1. Alright, so let's have a look at these examples. Which of the following has a limiting sum? So we've got A, B, and C. The first thing I need to do is I need to make sure that it's a GP, right? Because the limiting sum is only for GPs, not APs. So I'm going to look at the first one. I'm going to see if there's a common ratio. 15 over 16 divided by 3 over 4, 5 over 4. Now I might just stop there because straight away I know that the absolute value of that is going to be more than 1, so there's going to be no limiting sum. Let me just make sure that the ratio is the same just to show that it is a GP. 75 over 64 divided by 15 over 16. Also 5 over 4. Okay. So here we can see that the ratio is equal to 5 over 4. And the absolute value of that ratio is the absolute value of 5 over 4, which is 5 over 4. Now that's less than 1, therefore no limiting sum. What does that mean? It means that when we add all of these together, it's going to approach infinity, not some value. Alright, let's have a look at B. We can see here that the common ratio is going to be half. Right, 50 divided by 100 is half. 25 divided by 50, that's half. So it's got a common ratio of half. So the absolute value of that ratio is the absolute value of half, which is just half. And therefore, it has a limiting sum. Which means we can use the formula that we created before, or that's on our formula sheet, and work out what that is. Alright, see, we've got 3 plus 9 over 4 plus 27 over 16, so let's just see if there's a common ratio or not. 9 over 4 divided by 3 is 3/4. 27 over 16 divided by 9 over 4 is also 3/4, so good, we know it's a GP. So R is equal to 3/4. Now another way of proving this, proving that it has a limiting sum, instead of using this notation here, I'm just going to say -1 is less than 3/4, which is less than 1. Therefore, it has a limiting sum. Okay, so I hope you have a better understanding of what a limiting sum is. Just to recap, if we were to have a look at question A, for example, and we were to continue this pattern where it has a common ratio of 5 over 4, and we would add all of those numbers in the sequence, which goes to infinity, an infinite amount of terms, it's going to approach infinity. Because the ratio is 5 over 4. It's greater than 1. However, if we look at B, if we were to continue this series forever, 100 plus 50 plus 25 plus 12.5 plus etc., 6.25, forever, and we add all of those numbers together, it's going to approach some number, not infinity, right? We need to use the formula to work out what that answer is, what the limiting sum is, but it approaches or it converges to a limit because the ratio is less than 1. Or actually, should I say, the ratio, the absolute value of the ratio is less than 1. All right, let's have a look at part 2 of this lesson. So evaluating the limiting sum of a GP. So explain why 18 plus 6 plus 2 plus etc. is the limiting sum and find it. So to explain why it's a limiting sum, we need to show that the absolute value of the ratio is less than 1, or that the ratio is between minus 1 and 1. So let's have a look. Ratio 6 over 18, which is 1/3. Need to make sure it's a GP. 2 over 6 is also 1/3. Good, we know there's a common ratio, therefore it's a GP. And because minus 1 less than the ratio less than 1, that's a property we need to determine to show that it is a limiting sum. We can see here minus 1 is less than 1/3, which is less than 1, therefore limiting sum. Now how do we find it? Well, we know from our formula sheet that the sum is equal to a over 1 minus r. Okay, let's have a look at our formula sheet. A over 1 minus r. Well, a is the first term, 18. The ratio is 1/3. So we can put that in a calculator and see what we get. 18 over 1 minus 1/3 is 27. So if we were to continue this series forever, it's going to approach, when we add them together, it's going to approach 27. Alright, what about B? Explain why 18 minus 6 plus 2 minus etc. forever is the limiting sum and find it. Alright, maybe I'll get you to pause the video and have a go with question B and C. Okay, so in order for us to show that it is a limiting sum, we first need to show that it is a GP, that there is a common ratio. So the ratio here, we've got minus 6 divided by 18, which is minus 1/3. And for the second one, we've got positive 2 divided by negative 6, which is also negative 1/3. So there is a common ratio. And we know that we want it to be between minus 1 and 1, which it is. Therefore, limiting sum. Let's find it. The sum is equal to a over 1 minus r. A is 18. The ratio is negative 1/3. Maybe we can put that in brackets. And let's put that in a calculator. 27 over 2, or 13.5. Okay. Question C, find a limiting sum of 2 plus 1 plus half plus 1/4, etc. So we need to make sure that it's a GP. So common ratio, actually this one here doesn't tell us to determine whether it's a limiting sum or not. It just says find a limiting sum. So because it tells us to find a limiting sum, we can assume that it is a GP, and we don't need to prove that it's a GP. But what we really need is just to work out what the ratio is. And the ratio here is half, right? 1 divided by 2. So the limiting sum is a over 1 minus r, 2 over 1 minus half, which should be 4, I think. 2 over 1 minus half is 4. So we add these series forever. Okay, it's going to become smaller and smaller, 1/8, 1/16. Keeps getting smaller and smaller. is going to eventually add to 4. All right, question D. Evaluate the sum of all of these terms in this series. 2 times 2 thirds to the n, starting from 2, when n is equal to 2, all the way to infinity. So the common ratio here is 2 thirds. It's whatever is the base to the power of n. Whatever the base is, that's the common ratio when it's in this notation. The first term is when n is equal to 2. So we got 2 times 2 thirds to the power of 2. Which is 8 over 9. And now we should be able to work this out. Remember, because this is to infinity, we're pretty much saying the sum of n terms. So the limiting sum will be a over 1 minus r. We know it's a limiting sum because the ratio is 2 thirds, which is between minus 1 and 1. So we're going to use this formula. The first term is 8 over 9, and the ratio is 2 thirds. That gives us 8 over 3. So when we add all of them together, it's going to sum to 2 and 2 thirds. All right, question E. For what values of x does the series 1 plus x minus 2 plus x minus 2 squared plus etc. converge? So in order for it to converge, it needs to be the ratio needs to be between minus 1 and 1. So here we can see that the ratio is x minus 2, right? X minus 2 divided by 1 is x minus 2. X minus 2 squared divided by x minus 2, that's x minus 2. So we can see here that the ratio is x minus 2. Now, in order for it to converge, it needs to be between minus 1 and 1. So I'm just going to replace r with x minus 2. To get x by itself, I'm going to add 2 to every single term here. Minus 1 plus 2 is 1. X minus 2 plus 2 is x. 1 plus 2 is 3. And that's it. So we have found the values of x for which the series converges. Any value from 1 to 3, not including them. Okay. When the series does converge, what is its limiting sum? So the ratio is equal to x minus 2. The first term is equal to 1. So the sum will equal to a over 1 minus r. A is 1. And the ratio is x minus 2. Now remember, we have to put that in brackets because we're subtracting all of it. We're subtracting that ratio. I'm going to clean this up. This is equal to 1 over 1 minus x plus 2, which is just 1 over 3 minus x. So that is the limiting sum. All right, last question for today. Find the ratio of a GP whose first term is 10 and whose limiting sum is 40. Maybe I'll get you to pause the video and have a go with this on yourself. Okay, so we know the formula is S is equal to A over 1 minus R. We know that the first term is 10. We know that the limiting sum is 40. And we need to work out what the ratio is. So now I'm just going to use my algebraic skills, manipulate this, and work out what R is equal to. So I'm just going to swap these two. Okay, so we've got 1 minus R is equal to 10 over 40, which is 1/4. Okay, Now we can swap them like, in trig, where we've got sine of 50 degrees is equal to 7 over x. And we want x by itself, so we can just swap those two and it becomes x is equal to 7 over sine 50. That's our shortcut method. Well, we're just doing the same thing here. When what we want to find is in the denominator, we can just swap it with the other side. Right. I'm going to minus 1 from both sides. So 1/4 minus 1 is -3/4. And multiply both sides by -1, giving me 3/4. And that's it, we found the ratio. Just make sure that your answer makes sense, because this says it's a limiting sum. Our ratio needs to be between -1 and 1, which it is, so we know we probably did it correctly. Okay, if you had a ratio that's greater than 1 or less than -1, then you should realize that you made a mistake and go back and double check your answer. Okay, so that's it for this video. I hope you know how to explain the concept of what a limiting sum is now and actually use the formula to evaluate the limiting sum of a GP. Have a great day, and I will see you in the next video. See ya.